Daniel, it's been long overdue, and I don't know a time that I've been more excited to have a guest and friend on. You and I have known each other for the better part of the last 2 decades. And I always remember back to the first time that we met there, I believe at a crepe shop in Austin. And walking away, you had made a statement that ended up being pretty prophetic. You had said that you believe the future of silicon, of semiconductor, was not hardware, wasn't silicon. It was actually the hardware or the software and firmware that would drive the innovations, the features and the innovations. And then as we fast forward to today, you can't turn a tech article without seeing hardware, software, co-development. And so I've always been curious to ask you this question. Who do you credit with shaping your thinking around that and the ability to see the future?
That's a great question, and you're reminding me of that. Younger Daniel definitely, I guess, saw things at least one way. I think really at the time, as I think about that, mobile phones were really evolving very quickly, and we could see that they were moving from really products that were meant to carry audio signals into complete computing platforms on their own. And yeah, I think the iPhone had been launched, and we saw what was happening with Qualcomm and Snapdragon. And I was living my existence at the time in the cell phone ecosystem. I was building products for cell phones, so it was a very exciting time. But even then, I could see that these things were going to merge very quickly as we started to see operating systems like Symbian and iOS and Android on the horizon. That these things were going to have to pretty much meld. And I felt like cell phones were going to be a proxy for all computing environments going forward. So that's really the basis of it. It was just an observation on what was going on in the cell phones at the time. It wasn't a person or a thing. It was really just the market.
Okay, so and I got to pull on this thread a little bit. You said a younger Daniel saw things a certain way. Have you shifted your view?
I mean, yes and no. I think what I didn't see back then was the extent to the re-verticalization of kind of semiconductors. When we first met, and for most of my career, it's been a merchant silicon market. So, kind of dedicated companies that were either designing or fabbing or doing both the chips themselves and selling them to end OEMs. Certainly, over the last 5 years, it's accelerated. But even back then, it was probably pockets of this where you saw the end companies themselves wanting to make their own chips. So the hyperscalers are now designing their own products. The automotive manufacturers are designing their own products, engaging directly with the foundry or IP vendors like ARM. And so I think probably I thought it would end at software, but it's actually going further all the way into the application.
Now, before we go too far into the conversation, I'd like for you to give our audience a little bit of an introduction to yourself. You're an anomaly in the industry, in a day and age where people change badges every few years. You started your career at Scilabs as a design engineer. Now you're CTO. Talk to us a little bit about your path and your journey there and what's kept you there for so long.
So I grew up in Texas, in the Dallas area, came down to Austin for school, and I was looking for internships in the worst of the dot-com bust. So it was a pretty terrible time to find a job. But I got very fortunate to find an internship with this company, Silicon Labs, who was designing radio chips for cell phones. And that's really what the company was known for at the time. And that internship, I fell in love with, the technology, the products, the culture, and I've stayed my whole career. So it's now been, I think, 23 years since that internship started. And I've done a lot of different roles inside the company. It's not been one thing. So I think I've had kind of several kind of parts of the career here inside the company. But I started in R&D. I'm in R&D now. In between, I spent about 10 years on the business side and the corporate side, which really served me well now in a kind of a leadership role in R&D because I can partner more effectively with the business and the corporate functions.
I think all in the industry are happy you chose this route, but I do know something about you a lot of people may not be aware of. And before engineering, you actually almost became a professional classical musician, right?
Yeah, that's true. When I entered school, it was under a mechanical engineering degree program, um, but I was intending fully to switch over to music and become a professional musician wanting to play symphonies was the thing I really wanted to do. And I still love classical music and symphonies today. But a couple of years into that, I realized that was probably not the best career path for me. And the amount of jobs available and the dedication to the craft is all consuming at those performance levels. And I found myself becoming enamored with many other things as I was young and growing, and kind of the technology side of Double E, which I switched into, was starting to become very attractive to me.
Very cool. Do you think that that creative pursuit has shaped your thinking, either at your creative mind from an engineering perspective or from a leadership perspective?
I mean, for those who've gone very deep in the musical world, there's you start to realize that every single person has their ceiling, and hitting through that ceiling requires intense dedication and grit and grinding through it. Like there's just nothing that will get you through it faster than, or nothing that will get you through it except persistence, dedication. And I use that a lot in engineering. I mean, there's times when you hit hard problems and engineers want to find clever solutions that get you there fast, but sometimes there's not. Sometimes you really have to grind, and you really just have to put energy and effort and kind of curiosity into finding the best solution, because it's very nonlinear, that progress, especially when you're at the state of the art, when you're at the leading edge of innovation. It can feel like you're banging your head on a wall forever until all of a sudden you have the breakthroughs that happen. And in hindsight, it's obvious, but leading through it, it's very, very hard. So having that determination, really, I draw on kind of the tough times of getting through the toughest parts of music to get me there.
Very cool. And later on, we're going to talk about some of the home runs, but I think this is a really good segue and opportunity to talk about some of that the times that it's taken that grind and that persistence to get through it. Is there, rather than just talking about the home runs, I like to talk about the challenges as well. Is there a particular challenge that you can encounter, a memory that you have that took that grit, that persistence, and the lessons it taught you along the way, that has shaped either you as a leader or Sci Labs as a company for the better?
Yeah, I mean, there are definitely times when you realize it's a long road. And are you going to be able to see that thing through? Are you going to be able to stick it out? Are you going to be okay with the kind of intermediate wins or setbacks that you have along the way as you go? And several times I've been a part of these or kicked them off myself, not knowing, really understanding how long it was going to be. Um, I guess a couple that come to mind is I was part of an acquisition, or I got to participate in an acquisition Scilabs made in 2007. And at the time, we were making a big push into the China markets, and we bought a company in China, and I got to the opportunity to move to China. And there I was, very young and a fish out of water, couldn't speak the language. And I was kind of in a big team that was trying to do a lot of innovative work. And I mean, that was a moment where I was like, I need to just really dig deep here and, learn as much as I can, hold on to the things I need to hold on to at the same time. And if we're going to get this done, and that was a multi-year journey of getting some really good products built, um, a lot of personal growth in there, not especially living in a place where you don't really know the language, and it's a very foreign culture to me at the time. I grew up in suburban Dallas. Going to southern China in 2007, Shenzhen was as far away as you could possibly get. Maybe the moon was further, but not much. Um, so to stick that thing out and really make it the right way is something I'm very proud of. I mean, another piece is the business that we have now. So Silicon Labs today is an IoT company, but most of our history, that wasn't the case. It was really mixed signal engineering, kind of pointed at different end markets at different times. And there was a moment when we realized we needed to kind of put ourselves in one market and sit there and learn and evolve with it, the way Qualcomm did in cellular or Intel did in PCs. And that's a long road to hoe. Especially, we picked the embedded markets to do this, the IoT markets, and we knew it was going to be a decade to 2 decades to grow with it. And so, can you really see that thing out? Can you really grow with it, even if it ebbs and flows at its own rate? Can you go with that? And so, we're still doing that today. And sometimes I wish we could accelerate it all super fast because it's all running in one direction, anyways. But playing it through is really important.
Absolutely, and you guys have helped really define many of the protocols that we rely on. What has the company consistently gotten right as connectivity has evolved?
Great question. I think from a connectivity angle, the company was founded on taking basic, I'll say basic technology, and I use that word very loosely because all semiconductors is extremely complex. Okay, we know that building transistors out of sand is very hard. But we wanted to take standard CMOS technology and apply it in ways that would allow it to the cost to come down, the performance to come up, the accessibility to come out, and we've done that consistently in the IoT. So you do not need advanced wireless capabilities or expertise to use our products. You do not need big batteries to use our products. You do not need a complicated PCB to use our products. Like making the products easy to use from a connectivity angle is probably what we do best. And that's not an easy thing to do because wireless to many, even many double E's, is like a black art. How does it work? So we've done that. And so our wireless technology is in pretty much every end market. So industrial, consumer, health, um, retail applications, automotive applications. It's pretty pervasive at this point. And so one thing we got right from the beginning was make this stuff easy to use, make it easy to embed into the embedded application without changing that application itself. And that's an important piece of it because most of the IoT is applying wireless to things that already existed. And if we came into those customers and said, hooray, now you can do this wireless connectivity, but you have to change everything you do, then it would really inhibit the market growth. So we really wanted to make it easy to use, easy to adopt this wireless into these applications without changing too much the power, the cost, the usability, the software profile, or anything like that. And from there, we expand. And these products are now in their second or third generation of IoT where they're cloud connected from the beginning, or, I mean, really cool stuff is happening right now.
Absolutely, and as those cool things are happening, we're in the very early innings of another evolution, really, which is the age of AI. And with the growing complexity of connectivity and the rapid scale of data transfer, what's rising to the top? What's surfacing or bubbling up on the radar as key trends for Scilabs over the next 3 to 5 years?
Great time frame because 0 to 2 years is pretty much set already. 3 to 5 is really exciting. I think the two biggest things that are going to happen from like an IoT perspective over the next 3 to 5 years is we're going to see software make the turn, the pivot, formally and finally, away from kind of a super constrained, bare metal, kind of world, C main loops into full blown operating systems. And just like in PC, just like in data center, just like in mobile, that transition really just allowed those applications to take on so much more. So that's one thing is we're going to see RTOSs pervade. And tightly coupled with that and not far away is the AI that's coming down the pipe. So we're already seeing the impact of AI in embedded, but it hasn't really hit embedded too hard. So edge AI is a term that a lot of people are using, and it's here. It's in the market today, and you can buy products, if in any end market that have some of these capabilities in there, but it's nothing like it's going to be in 5 years. And so all the silicon vendors, Scilabs included, are building products that are AI forward and AI first. And that means the right hardware, the right memory. I mean, the same things that you're seeing play out, the same concepts you're seeing play out in data center and in mobile are taking place in embedded. So you'll see these end applications become a heck of a lot smarter, a heck of a lot simpler to use. And at the end of the day, you're going to see them become a kind of integral piece of the segmented compute hierarchy. And so a lot of these end nodes are going to be the primary place that AI runs. And you will backflow into a gateway to the data center only as a necessity, either because you're not quite sure that the algorithms aren't resolving properly, or because they are an important piece of creating the next generation of data sets for training. And so there's this like thirst for the raw data that's happening in the real world because you can only get so much by harvesting Instagram or Facebook or the web itself. Eventually, you need that real world data, of which there are billions and billions of these devices out there they become tied into collecting the next generation of data sets. But you really only want the data that matters. You don't necessarily want to collect it all because most of it's not useful, only the stuff that's corner cases. But finding them becomes very, very valuable. So you're going to see a lot more data flowing over the air. You're going to see a lot more smartness in these end applications. And I think there's a lot of really cool, innovative things my customers are working on today that I look forward to being able to tell you about later on.
And we'll definitely look forward to that. Switching gears a little bit. So recently, Wall Street Journal ran a headline that said that Austin's reign as a tech hub may be coming to an end. And I have, and I've actually recently posted my own thoughts on that. But as someone who's actually helped shape Austin's tech ecosystem, what's your take?
There's more tech jobs in Austin every year. It's changed over the years. If you go back to the 90s and 1995, 2005, 2015, 2025, I mean, it's been evolving just like every tech landscape here. But at this point, I mean, Austin is very much a tech city, and it's very different than the city I moved to when I came here in 2000. Whether it's the software ecosystem, the big tech companies that have maybe their biggest engineering teams in their company here in Austin, Texas, I mean, it's pretty radical what's happened compared to again where things were 20 or 30 years ago. So what we're not seeing is an overall reduction either in jobs or companies. Every kind of market goes through its ebbs and flows, ups and downs, but I'm not seeing that at all. Some of these articles kind of over-index on VC investment from time to time, and they say, "Oh, the VC money must mean tech or not tech." I mean, Austin has a lot of VC that's moved here, especially post-pandemic or in the pandemic. A lot of it moved. So, I mean, what you're seeing is honestly, in my opinion, there was kind of a huge shift into Austin during the pandemic. I mean, house prices went up. I mean, it was pretty nuts, and some of those people are leaving now. And not everybody liked it. And so I think that's what you're seeing through in the media. But the Austin tech scene is great. And the university is a big part of it. So the education, the state is applying a lot of resources like the Texas CHIPS Act, the Space Act that came through. We now have advanced manufacturing with more foundries that are being announced. We have Tesla's automotive factory here. So, I mean, there's a lot of really cool stuff happening in Austin.
Absolutely. What do you think sets Austin apart, and why do engineers keep choosing it?
I mean, I lived in the Bay, and I lived in Austin, lived in Singapore, and I lived in Norway, Oslo. Every place is different. Every place has its pros and cons, and if you tell me why are these other places great for engineering, I could tell you why they are. But for Austin specifically here, it first is a pretty balanced cost of living for young people compared to other tech hubs that may be out there like New York or the Bay Area. So first and foremost, it's a great place to start your career, and you want to be in places where it's a great place to start your career. Secondly, it's a very wide cut of the technology landscape. So there's a really good mix of everything from defense spending, like we have, the Army Command is here. We have a big Air Force presence in San Antonio close by. There's a lot of just defense spending that happens here. There's a lot of semiconductor investment that happens here, not just on the foundry side from Samsung or Micron or others, but on the design ecosystem side and the IP side. So there's fabulous companies like Silicon Labs and AMD and Intel is here and ARM is here. Like these big companies are here. Apple is here. And then we have a thriving software ecosystem as well. So there's been a lot of software companies that start and get acquired. Ultimately, there hasn't been any big IPOs that stuck. But it's a great place to kind of be a part of the startup ecosystem, and there's a lot of good startup incubators. Great University of Texas has great technology and engineering programs. I mean, there's just a lot of the factors here that people really love. And Texas is a very business friendly place very business friendly, very good spot. So a lot of headquarters have moved here. Oracle, their headquarters is in downtown Austin now. We have Dell here. So, I mean, there's a lot of pieces why I think Austin is a great place to be. And, I've lived in a lot of places, and I overall, I think the kind of cost benefit equation here is one of the peaks.
Well, and harkening back to the beginning of our conversation, and we were talking about your eerie ability to forecast the future. I think any young engineer would be wise to heed your advice. And with today's fast moving AI driven landscape, what advice would you give to a young double E who's just starting their career in the semiconductor industry?
It's the same advice I would give without AI. I think it's just even more important now. I mean, you've got to commit to mastering the fundamentals. Being able to answer that question, why does something work, is so foundational, because as you move further along in your professional career, it's about getting things done. And and you can very quickly become disconnected for the why. Why does it work? How does it work? And why does it matter? Because there's plenty to do once you're working in the companies. If you have that context and that foundation of understanding the basics, I mean, the basics of basics, then it gives you a very broad understanding of what's coming next, how you compete, um, how things will change over time, and generally why they are the way they are. So master the fundamentals is something I tell everybody, and that'll give you a really, really good foundation to do whatever you want to do.
What are two aspects of the Silicon Labs culture that don't get enough airtime, or that people may be surprised to hear that you'd like them to know?
I think one thing that stands out, Justin, is we are. I don't like this term a lot, but I'll use it today. It's like I think we're full stack, silicon to cloud under one roof, and we do real engineering and real innovation at all of those levels. So down from the foundry engineering up through cloud software, we're one of the few places that can do that, and you can see all the pieces and how they connect, and it's at a scale where it makes sense. So, from inside of our culture, there's this kind of complete understanding of the product that is foundational to building great products. And I'm very proud of the products that we build and we deliver. Um, I think that allows people to, satisfy their curiosity on how things work. It allows them to maybe change roles adjacent to what they do a lot easier. If you're an analog designer, you want to go digital designer, you want to go do firmware, you want to move into tools or the cloud. We have that career path here that I don't know if it exists at scale in other places. Um, I think the one of our company values that I like the most is do the right thing, and it's on the wall in every conference room, and we preach it, we live it, we love it. It's this idea that just do the right thing. And process needs to exist, but if the process isn't enabling you to do the right thing, you can call it, you can talk about it. If there's a lot of data points aligning for short-term priorities versus long-term priorities, there's a mechanism to call this out and talk about it. And so do the right thing is something I hear almost every day, if not every week. We take that seriously. And from the founding of the company, it was based on make sure you're doing the right thing, that the end goal is what matters, and that we need to build processes for those end goals instead of building processes for the process sake.
I love it. And, one of the oft overlooked elements of being a CTO, it's not just being about a great technologist, but you got to be able to sell ideas too. And so I'm going to give you a chance to put your sales hat on. If you were talking to a young engineer or an experienced one who didn't need a job, but was curious about Scilabs, and you wanted to convince them to come over to at least give it a shot, what would you say?
I mean, Scilabs for an engineer. I mean, engineers really care about the products and the technology that goes into them. And I think we've got the best products in the market, and we intend to keep building them and innovating. We're first in a lot of different dimensions, not just in connectivity, core processing or machine learning or security. We're really at the forefront, defining the frontier of customer use cases, regulations with the governments, industry standards, and we've done that over and over again. I mean, if you want to come work on premier products at a place where the engineering is valued, this is a spot to do it.
Beautiful. And we've done a lot of talking about Scilabs and the IoT markets, et cetera. Talking about you, we're both at the point where we're probably on that second half of our career journey, and you've got a ton more to offer. But when you think over the next decade or so, you got to start thinking about legacy. What kind of legacy would you like to leave?
I mean, I live my life in two places. I live it at home with my family and at the job. And I've got a big family, and that's a very important part of my life. I'd like to optimize a little bit for both. I like to be present for my children and involved and integrated into that, and I think I've found that balance. Um, that being said, I think that I have a chance to influence something that rarely happens, which is creating a kind of permanent franchise in our business. And our business is very ephemeral. Like the tech moves super fast, and the semiconductor investment cycles are super long. There's so many ways you could mess this up, but I'd like to create a franchise in embedded computing that is becomes the gold standard. And when I say embedded computing, I mean the aspects of the embedded system, such as the compute side, the machine learning, the security, and the connectivity as the four pillars of that. And that's up for grabs. It's a very fragmented market today, regionally, end market, in segments. There's hundreds of thousands of customers. It's ripe for an integration, not integration, consolidated kind of platform play. It's the last market that this exists in. So that's up for grabs now over the next 10 years. I think the winners are going to be picked in the next five. And after then, it will become obvious who they are. So I think, from a market perspective, it still needs lots of great technology and products to make that happen. And I want to build them. I mean, that's really it. So it is not necessarily just about Daniel. It's really tied to the success of the organization. And I think we've got a really good shot to be the one to do that.
Excellent. Well, your time is valuable and it's very much appreciated. The insights that you shared with the community are going to be far-reaching, and I hope that we can make this an annual event, and that next time we are talking about some of those products you alluded to earlier that your customers are building.
Well, thanks for having me on. I really appreciate it. It's great to catch up. You're touching a lot of companies these days, and I'm definitely following what you're doing too.